Strings are objects. As we have learned before, string is not one of the basic data types. The basic data types, there are integer basic data types, real number basic data types, a basic data type for characters, and a basic data type for Boolean values. But there are no basic data types for strings. Strings are objects. So we have to use a class to create a string. In order to create a string, we use the string class. String is one of the basic Java classes. And by using the string class, we create string objects. Here we see in this. Sorry, do you see my screen? Or do you hear me, first of all? I think I'm sharing my screen, so you are probably able to see my screen. Any questions? Okay, I will continue. So since strings are not basic data types, we cannot compare strings by using the equality and relation operators. Okay, we have to have some other mechanism to compare strings. In order to check two strings, in order to check for equality of two strings, we have to use the equals method. How do we write? We write before the equals the first string object, followed by a dot, and then the equals method. And as an argument inside the parentheses, we give the second string. So first string dot equals, and between parentheses, the second string. So this is how we do it. And what does this return? This equals method returns true if the string before the equals is equal to the string inside the parentheses. Okay, if this S1 is equal to S2, therefore then S1 dot equals between parentheses S2 gives me true. If the strings are not equal, then it will give false. As I said before to you, let me open here a document. Let me make it bigger and a new. Okay. If I have, for example, one string called Antalya, it is not equal to Antalya because in the first one, there's a capital A. In the second one, there is a lowercase a, and a capital A is not equal to lowercase a if we do a case sensitive comparison. Okay. If you do case insensitive comparison, they are equal. So we can say that there are two types of string comparisons. One is case sensitive comparison. The other one is case insensitive. In case sensitive comparison, uppercase A and lowercase a are different. In case insensitive comparison, uppercase A and lowercase a, uppercase B, lowercase b, uppercase C, lowercase c, etc. are equal. So equals does case sensitive comparison. So when I compare these two, they are not equal. Okay, so I can write that they are not equal. Therefore, if my strings are Antalya and Antalya, in such a statement, with this type of statement, if I write, for example, if S1 equals to, sorry, I just make this something like that. If, for example, S1, of course, in order to make it valid, I have to write string S1 is equal to Antalya. Let's close the let's put the semicolon. String S2 is equal to Antalya. If I compare them using this statement, then they will not be equal. Of course, I have to put another parenthesis because if statements in Java always require a parenthesis, and the logical expression or the Boolean expression must be between the parentheses. Here, this gives me either true or false. Okay, from here I get either true or false. If S1 is really equal to S2, for example, let's put here capital A. In this case, this will be true. Then what will happen? It will execute the statement here. Okay. 1 second. Alo Nesrin. Ya ben şu anda online dersteyim. Sen beni saat yani 7'den sonra arasam memnun olurum. Ya da ben seni bitince arayayım. Yani kusura bakma. Hoşça kal, iyi günler. So if S1 and S2 are case sensitively equal, like here, they are all characters are same, then S1 that equals S2 will be true, and the inside if will be executed. If they are not same, then the else part will be executed. Okay. There's another equals, which is equals ignore case, which compares them case insensitively. Okay. In that case, for example, Antalya and Antalya will be equal because capital A and lowercase a will be treated as same. And let's put here, for example, Antalya with capital L. This lowercase l and uppercase l will be treated as same in equals ignore case. So if I want to compare two strings case insensitively, let's case insensitively, compare case sensitively or case insensitively, then in that case this will be true because A and A, then the second character N and N, T, T, A, L, L, Y, Y, A. So all characters are same. So the result will be true. And what about comparing for greater than, greater or equal, less than, less or equal? In that case, we use compare to. In that case, we have to put here either greater than 0, or instead of greater than 0, I can put greater than or equal to 0, or less than 0, or less than or equal to 0. In that case, we don't have any true or false. Okay, let's do it like that. In this case, if S1 is lexically greater than 0, showing S greater than S2, if S1 is lexically greater than S2, then the result, this greater than 0 will be true. Okay, this will return a positive number if S1 is greater than S2. If S1 and S2 are same, exactly same, then it will return 0. So compare to gives us an integer number. Okay, so since it gives us an integer number, here we have to have either greater than 0, greater or equal to 0, or equal to 0, or not equal to 0 for not equality, or less than 0, which if it's a negative number, it means that S1 is smaller than S2. Okay, if S1 is greater than S2, this gives me a positive number. If S1 is less than S2, compared to gives me a negative number. So when I check this, it means it means that, let's write here system dot out dot println. I would do this anyway. Let's take this copy and let's run it in here. System out string 1 is less than string 2. And let's take this here from here, copy it there, and put here is greater than. Now let's run the program. We don't need these things. Okay. Now I will run the program. Now it will ask enter first. It will print enter first string because here we have enter first string blah blah with print, no println. Therefore it stays on the same line. If I had println, it would go to the next line and would input from the next line. Let's enter here Antalya. And then enter second string Antalya. Okay. Now this has less characters than the first one. When we compare strings, the number of characters has no meaning at all. Okay, it is not. It doesn't mean anything to have more character or less character. What counts when we compare strings is their code. Capital A is less than lowercase a. Therefore, this string is less than this one. Okay, and let's put this. String 1 is this. String 1 is less than string 2, because when we compare A and A, lowercase a has smaller ASCII code. Did I show you the ASCII code table? The previous lecture. Let me show it to you. Not here. Okay, ASCII tables. This is our ASCII table. The code of the space character, space character is followed by a number of characters, punctuation characters, parentheses, etc., some special characters, and then character from 0 to 9 follow each other, followed by some other characters, and then characters from capital A to capital Z follows that, and then after some more characters, like here, we have lowercase a to lowercase z. Okay, so all you have to know is space is before 0, character 9 is before capital A, and capital Z is before lowercase a. Although I'm writing computer programs for 46 years now, I don't know the ASCII codes of those special characters. Okay, I don't need to know them. Okay, all I know is that space is before 0, capital A is before 9, and capital Z is before lowercase a. And of course, the letter characters and the digit characters follow each other. Okay, that's all I know. So when you know this, you would probably know that when you compare, for example, this and this, you know what is the result. Or when I have, for example, A on for blah blah, some digit characters, and I have here on 8 D 0, for example, etc. Or let's put here one space only. Anyway, so when I compare this, A and A are same, N and N are same, then followed by space and space are same. When we compare 4 and 8, which is smaller, 4 is smaller, or the code of 4 is before code of 8. Therefore, this string is smaller than this one. Although it has more characters, as I said, the length has nothing to do in string comparison. So we just compare character by character. If instead of 4, let's put here 8 again, and then followed by 7 and D, which is first, we know that the digit characters are before alphabetic characters. Therefore, 7 is smaller than D. Okay. Or if I have here, for example, A, the first 4 characters are same. The next character here is lowercase a and uppercase D, which is smaller. The uppercase characters are smaller than the lowercase characters. So I know that D is before A, therefore S2 is before S1, or in other words, S2 is smaller than S1. As I said, not because of the length, it may be some other characters, but because here we have capital A, so lowercase a, which is after uppercase D, therefore this string is smaller than this string. And how do we, what I will get from S1 dot compared to S2? Since S1 is greater than S2, it will give me a positive number. So if I want to check if S1 is greater than S2, what I really have to do, put here greater than 0. I have to write my statement like this. Now let's go to our program. Here, I'm checking first if they are equal or not with equals. And then let's say, let's put here greater than and greater than string blah blah and less than. Since equality is checked here, now I know that when I come to else, I know that S1 and S2 are different. Okay, they are not equal. Therefore, the result of compare to will not be equal to 0. Instead of equals, let's take this one from here, Control X. Let's put here this. What I can do, I can copy this, put it here, but instead of equal greater than, I can put 0. Okay, so S1 equals S2 will be equivalent to S1 compare S2 is equal to 0. Okay, these two are equivalent. If S1 and S2 are equal, then the value returned by the compare to method will be equal to 0. If it is 0, if compare to gives me 0, it means that S1 and S2 are equal. If it is greater than 0, it means that S1 is greater than S2. If the result of this is less than 0, it means that S1 is less than S2. We compare it with 0 all the time. So this is about comparing strings. Equals compare to. If I want to compare case insensitively, what I can write? I can write here compare to ignore case. And same thing, let's take this, Control C and put it here. Compare to ignore case compares two strings case insensitively. So lowercase character letters and uppercase letters will be treated as equal. So we have four functions, four methods: equals, compare to, equals ignore case, and compare to ignore case. Okay, let me write it here. So our methods are this: S1 dot equals S, the other string, or instead of this we have equals and ignore case written exactly like this. I is capital and C is capital. And let's take this and put it here. Compare to and compare to exactly same here. Okay. So we can compare two strings for equality case sensitively using equals. Compare two strings for equality case insensitively, ignore case. Compare two strings for less than, greater than, etc. case sensitively, use compare to. Compare two strings for less than, greater than, etc. case insensitively, use compare to ignore case. We use these four method calls for case sensitive and case insensitive comparisons. Is this understood? Then we can continue with switch statement. This is something new. The switch statement doesn't exist in Python. It exists in Java, in C, C++, etc. In some other languages. What is the purpose of switch? In switch statement, we check the value of a variable or an expression. It can be not only a variable but also an expression. But that variable or expression have to be either an int or byte or short, char, or string. It cannot be anything else. Okay, it has to be one of these. It cannot be Boolean, not long, not a floating point value, double or char and double or float, etc. It must be either int, byte, short, char, or a string. We check the content written here in the switch statement against individual cases. For example, assume that this is a character variable, a char variable. Okay, if it is equal to uppercase A, it will perform this. If it is equal to B, it will perform this, etc. So we are checking an individual int or byte or short or char or string expression or variable against specific values. Let me open from here a switch example. Here I have three variables, n and k and m. Here we are checking for n. If n is equal to 1, it will do these statements and then break. Why do we use break? Because if we don't use break, for example, if n is equal to 2, in this case, n is equal to 2, and we have a switch statement that uses the value of n. If n would be equal to 1, it would execute this, and then break comes. What does mean break? Break finishes and goes after that statement. It will go here. Okay. If it doesn't see any break statement, it continues. If n is equal to 2, it will do this and continue until it finds a break. It will do this and break. If n is equal to 3, it will do this and break. So here, what is the situation in this case? If the value of n is equal to 2, it will assign 22 to k, 32 to m, and then break. If it is equal to 3, if the value of n is 3, it will only do this and break. So this has some this gives us some flexibility. If in one case we do the same thing in another case, but some extra stuff, we put that case before, we don't put any break and it continues. Of course, this is rarely done, but this is a possibility in this is a flexibility and possibility in Java. So basically, for example, let me write another one. We don't use doubles in switches. In that case, we have to use some if-else statements. Let's assume I have I will use here another switch statement. Int class 1. Class 1 for the class of a student in a university. What I will do, I will write a switch statement for class 1. And here let's write a case 1. If it is 1, what I will do, I will write system dot out dot println freshman. The first year student is called freshman in a university, so it will print to screen freshman. And then we will write here a break. We finished the first case. What I will do, I will copy this and repeat a few more times. Case 2, if class 1 is equal to 2, it will do the case 2 part. If it is equal to 3, it will do this, and if it is 4, it will do that. Freshman, I think it was sophomore, and then junior, and the fourth year students are called senior students. So let's put it here, for example, 3. Okay, let's run this. What it will do, we will see here junior. Why we see junior? Because class 1 is equal to 3. Therefore, in switch class 1, since the value of class 1 is 3, it jumped to case 3. It executed until the first break. What I will do, and here default. What is default? If the value of the variable or expression here is not equal to any of the cases, if it's not equal to 1, 2, 3, or 4, if there's something else, it will continue with the default. Okay, let's copy this. Wrong class, for example. I don't need to put any break because it is at the end anyway. Okay, so we don't need to put any break for the default because this is just already the end of the switch statement. If it finds a break, what it does, it continues with the statement after the switch. Let's put here, for example, 7 and run this. We see that it will print wrong class. It is not equal to 1, not 2, not 3, not 4. Therefore, it will go to default and do the statements below the default case. Is it understood? Switch is simple. This switch, let's copy this. I will put it somewhere here. This is equivalent. Oh, there are too many stuff. Control A. I will make this smaller. Okay. I have this. Sorry. This is equivalent to what? Maybe it's better to write it. This is equivalent to this if-else if statement. If plus 1 is equal to 1, let's put here this. Just copy this to here. Else if plus 1 is equal to 2, then put here parenthesis and copy this here. Etc. etc. So this switch statement can be written using a nested if. And similarly, let's continue with this. And at the end, else from class equal to 3 and 4, senior and junior. Okay. So this switch statement performs the same thing with this nested if-else if statements. Okay. If class equal to 1, do this. Otherwise, if class equal to 2, do that, etc. etc. Of course, we can have other statements here. Okay. We could have some more statements, and similarly, of course, we can have some more statements here. There is no limit of we can put any number of statements before a break. It's not limited to one statement. We can have multiple statements here in the cases. And similarly, we can have multiple statements, of course, in if blocks, in these blocks. I hope this is understood well now. Any question about switch statement? Okay, let's continue with the next section. If you have no question about switch statement or no question about comparing strings, I will continue with the for statement. Any questions? Okay, let's continue with the for statement. The for statement in Java is quite different from the for statement in Python. So you have to be very careful here. In a for statement, we have several parts. How do we write a for statement? After for, we put a parenthesis, and inside parenthesis, we have three areas. Copy this, go here. What are these? We have an initialization part, followed by semicolon, a condition. When I say a condition, it's a logical expression which is either true or false, followed by a semicolon again, and an increment-decrement part. Let's write an example. For here, I can define a variable. Okay, in the initialization part, I can define a variable. For example, int j is equal to 1. Define a variable and initialize the variable. As long as j is less or equal to 10, increase j every time, and inside the parentheses, let's, for example, write system dot out dot print ln and j. What does this do? Let me copy this. Probably it will be better to show it in here. Yeah, here we have something very similar to it. Here I have for int n equal to 1. As long as n is less or equal to 7, it will do. And after doing inside the block, it will increase n. How does it work? This part is done the first time, only once at the beginning, okay? So in such a statement, the initialization is done first. So what is the order of execution? First, the initialization is done. And then the condition is checked. If the condition is true, then the for block is executed. After the for block is executed, the increment-decrement part is done. After the increment-decrement part, let's put here, insert a shape of this type. From here, it goes back to here, okay? So initialization is only done one time, then condition is checked. If the condition is true, here, let's say if condition is true, the statements in the block are done. There may be one statement, two statements, 5, 10, 100 statement, doesn't matter. All the statements in the block are done. After this is done, the increment decrement part is done. After the increment decrement part, it always continues by checking the condition again. As long as the condition is true, this block and increment decrement part is repeated. So let's go back and look here. Let's examine this one. Sorry. Here we have that. N is equal to, N is assigned to 1. So let's write here. What are the value of N? And what is the output? Output, which is the result of the system println blah blah. Let's make this slightly bigger. At the beginning, N is assigned 1. Okay. After this, what do? We check the condition. Is 1 less or equal to 7? Yes. Therefore, what happens next? This inside the for statement, the block of the for statement is executed. So N is printed. So what will happen? 1 is printed. After this, what happens? After the block, what do? We do increment on decrement. So N is increased by 1. What is the value of N? Is 2. After increment decrement, we check the condition again. Now the value of N is changed. It was 1 before, but now it is not 1 anymore. It is 2. 2 is less than 7. Yes, that's true. Therefore, the print blah blah is done. Therefore, 2 is printed to the screen. And then the increment decrement part is done. N plus plus means increase the value of N by 1. So from 2, it will increase to 3. Is 3 less than 7? Yes. Less or equal to 7? Yes. So 3 is printed here in system out println, and N plus plus is performed once more. So the value of N will be 4. 4 less or equal to 7? Yes. Increase, print the value of N. Go and increase by 1. So it was 4. It will be 5. 5 less or equal to 7? Yes. Print 5 using system out println. Come here after the block. We always execute the increment decrement part. Therefore, N is increased by 1. So it becomes 6. 6 less or equal to 7? Yes, it is true. So print. Here we have just print, but it may be something else. I will do another example with something else. After printing, we increase the value. Now it is 7. 7 less or equal to 7? Yes. Print N, which is 7. Increase the value of N by 1. What is the value of N? Oops, sorry. Now it is 8. 8 less or equal to 7? No. False. Therefore, 4 is finished. It will continue with the statement after it. Okay. If there is anything here, if there is there will be some statement after it, then it will be executed. So it will print 1 to 7. Now I will change this slightly. Here I will have int total equal to 0. Okay. And then these statements. And let's change this slightly. And instead of system out println, what I will have total plus equal N. So instead of outputting, we have just the value of total. At the beginning, total is 0. Okay, here we had set it to 0. So after int total equals 0, we set the total to 0. We come here, we set N to 1. From this previous example, we know that since n start with 1 and it increases every time by 1 with n plus plus, and as long as it is less than 7, here, let's remove this. It will be 1, 2, 3, 4, 7, up to 7. It will execute inside the for statement, but when it is 8, it will finish and go out. So here there will be some operation done, but not when it is 8. When n is 8, becomes 8 here. After n plus plus, making n equal to 8, 8 less or equal to 7 will be false, and the for loop will be finished, and it will continue with next statement. Now, n is equal to 1 at the beginning. 1 is less than 7. Okay, what happens? What is plus equal means? It adds the right-hand side expression to this variable. So total is increased by value of n. N is 1, 0 added 1, so it is 1. Next time, 2 is added to total, 1 plus 2, the result is 3. Next time, 3 is added to total, 3 plus 3, 6. 4 plus 6, 10. 5 plus 10, 15. 15 plus 6, 21. 21 plus 7, 28. So what it does, it finds the sum of all numbers from 1 to 7. Okay, this program segment, this Java program segment, finds the total of all values from 1 to 7. If I want to find the sum of all values from 1 to k, assume that I have some integer variable here, let's say int k is equal to 66, for example. If I want to find the value of all numbers from 1 to 66, what I will do, I'll put here k. Okay, start with 1. As long as n is less or equal to k, increase the value of n and also add that value, the n value, to total. So when I do this, it will find the sum of all numbers from 1 to k, or since k is equal to 66, 1 to 66. But when I look to here, this program part finds the sum of all numbers from 1 to k. Okay. Question. If I want to find the sum of all even numbers, not all numbers, not 1, 2, 3, 4, 5, but all even numbers, 2, 4, 6, blah, blah, up to k. What I will do, quite simple. Here, I will put a condition which checks if the value of n is an even number or not. So I will have something like this. If n is even, how do I check if n is even? N modulus 2 equal 0 means that n is an even number. Okay. When we divide by 2, if the remainder or modulus is equal to 0, it means that this n is an even number. So if I want to find the sum of all even numbers from 1 to k, my program will be something like this. Okay. Start with 1. Every time increase by 1. And as long as the value of n is less than or equal to k, 1, 2, 3, here in this loop, I'm generating 1, 2, 3, 4, 5 up to k. And every time for each value generated and put into n, I'm checking if n is an even number or not. If it is even number, add that number to total. And at the end here, of course, what will we have? We will have something like system.out.println sum of even numbers up to comma, not comma, plus k is plus total. We will have something like this, okay? Let's make this. So our program, let's for painter, let's make all of them same. Okay, so we will have something like this. That I will do. Let's diminish the so that it will fit on one line. Okay, that's better. So this program segment, or let's leave this out. This program segment finds the sum of all even numbers from 1 to the value of k. K is initialized before and printed. Okay, here we find the total of all even numbers from 1 to k. Here we generate all numbers from 1 to k, even or odd, doesn't matter. From 1 to k, all numbers are generated. And here we are checking if it is even number, if the generated number n is an even number. If it is an even number, then add that number to a variable that we name total. And here print that sum of even numbers up to is printed, the value of k is printed, and then space is printed, and then the total, the value of total is printed. One important point, this is a string. I had explained this to you before, but I think it is necessary to explain it once more. This is a string, this is a number, integer number, this is a string, and this is an integer number. If in Java we have a plus operator which has a string on one side, then the other item is automatically converted to a string and concatenated. In system out println or system out print, we have to have only one expression. It is not like the print of Python. In Python, remember in Python, we had, for example, print a, b, some string, x, y, for example. We can write things like this. We can have in a print statement in Python many items separated by comma. In Java, in system.out.print or println, we have only one expression. We don't have any comma. Don't put any comma in Java system out println. Write everything in one expression. If you need to print multiple things, just put a space, a plus between them. But if you have numbers, if you want to print several numbers, assume that we have, for example, have int a, a is equal to 4, b is equal to 7, for example, and c is equal to 24. If I want to print those three numbers on screen, what I will write on one line, put a, put a space after it, write b, put a space after it, and write c. Okay. If you want to print three numbers on screen, for example, you have to put the first number, concatenate a string which contains a single space, concatenate b, concatenate another string which contains one space, and print c. Okay. So in Java, if on one line you want to print several numbers, you must concatenate with spaces those numbers. Okay. This is how to do in Java. In Python, you can just say blah blah c, and it would print a space between a and b and between b and c by default automatically, but not in Java. In Java, you have to write it like this. Okay. Is this clear? So we can mix up these things. If I put here, for example, k plus total, then k will be printed and total will be printed just without not anything between them, and it will not be good. So we have to have something like this. Or at least sum of even numbers up to k. For example, we can put here equal or just colon, something like that. Okay, any string. Is this okay? Is this understood? Now, one nice thing about for loops in Java is that here I need not to use an integer variable. I can use a double or real number here. Okay. For example, let's write a program that has this. Here, for example, we are printing everything. Let's run this program first of all, and let's see what happens. It was the previous program. Those others on this program. Let's go to top. Here we have written print values from 1 to 7. And in this for loop, we have printed 1 to 7. Print values from -10 to +10 by 2. So I want to print -10, -8, -6, blah, blah, up to 8, excluding 10. Okay, not to 10, but excluding to 8, let's say. So what I do, I start, since the first value is -10, my initialization will contain that value. -10 is my value. From -10 to -8, what is the change of the value? It is by 2. So in the increment decrement part, I have n plus equal 2. So from -10 to -8, I have to increase the value of n by 2. And I want to print up to 8. 10 is excluded. Therefore, I have n less than 10. So this for loop will print these values. Okay. So my increment decrement part need not to have only plus plus or minus minus. It can change the value by 2 by 2. Assume I want to print from all 2-digit numbers divisible by 10. What are the 2-digit numbers divisible by 10? They are, I want to print, for example, 10, then 20, 30, 40, blah, 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 up to 90. How can I achieve this with a for loop? What I will write, my start value is 10. As long as it is less than 100, I will increase the value of 10, the value of n by 10, because from 10 to 20, let's remove these things. Let's remove this. My first value is 10. Every time I am increasing that value by 10. So here, my initial value is equal to 10. Then every time I increase by 10. For all these values, 10, 20, 30, 40, up to 90, that condition must be true. So what I can write, I can either write here less than 91, for example, or less or equal 90 would also be correct. As long as it is less than or equal to 90, continue. Or what I can write, less than 100. Why? Because the next value after 90 will be 100. Okay, 90 is printed here. System dot out dot print ln n, for example. After printing 90, n is increased by 10. It becomes 100, but 100 less than 100 is false. Therefore, it will not do this. It will finish and continue with the next statement. So for this, it will print, but it will not print 100. the last value of n in the loop, because this condition is not true for 100, but the value of n will be 100 because after 90 it will continue increasing, and then check the condition. Since the condition will be false at that time, it will finish the loop and continue with the next line. Let's change this. Let's start with 10. As long as it is less than 100, increase n by 10. Let's run this program. And let's see if it does correctly. As we see, it printed the values from all 2-digit positive integer numbers divisible by 10. The question can be something like that. Okay. Write a for loop that prints all positive 2-digit integer numbers divisible by 10. Okay. Is this understood? What happens if I have 5 here? Write a for loop that prints all positive 2-digit integer numbers divisible by 5. So what are those numbers? 10, 15, 20, 25, 30, 35, 90, 95. Okay, these are all positive 2-digit integer numbers divisible by 5. How will be my for loop? Forget about this. It will start with 10. The first value is 10. Every time the increment is 5. So increase by 5. 95, 90, blah, blah, all. For all of these values, this condition will be true. What will be the next value? Let's go here. In the for loop, after printing 95, here, after printing 95, it will come here, increase the value of n by 5. So the next value will be 100, but it should not print 100. So what I can write, n less than 100 will be correct. Okay, is it understood? Okay, next, 3. All positive 2-digit integer numbers divisible by 3. Is 10 divisible by 3? No. What are the values in this case? What is the first 2-digit positive number which is divisible by 3? Who will tell me? Quite simple question. What is the smallest 2-digit positive integer number divisible by 3? It is 12, isn't it? Yeah. So it is 12. We will start with 12. Then the next one, 15. Next one, 18, 21, 24, 27, 30, 33, etc. As long as it is less than 100, it is a positive 2-digit integer number. So I will start here with 12. Although it says positive 2-digit integer number, the smallest positive 2-digit integer number is 10. But my first value that will be printed will be 12. So I have to start with 12, put here 3. And again, as long as it is less than 100, it's a positive 2-digit integer number. Okay. Positive 2-digit integer number means that it is less than 3. What is the biggest number that will be printed? 99 is divisible by 3. Now, next question. In decreasing order, write a for loop that prints all positive 2-digit integer numbers divisible by 3 in decreasing numbers. So what is the biggest one? 99. Then before that, 96, 93, 90, up to 12. Now, what will be my for loop? It will start with 99. As long as it is greater than 9, 10 or more, it is a 2-digit number. Here I will have minus equal 3. Start with 99. Every time decrease by 3. So n minus equal 3 is my increment-decrement expression. Okay, statement. As long as it is greater than 9, 10 or more is a 2-digit number. Now it will print in decreasing order. Write a for loop that prints all positive 2-digit integer numbers divisible by 5. What is the biggest 2-digit positive integer number divisible by 5? What is my first number? 95. Then 90, 85, 80, etc. 15, 10, and finished. These are all 2-digit positive integer numbers. Let's put this positive after 2 digits. Two-digit positive integer numbers divisible by 5 in decreasing order. Since I want them to be printed in decreasing order, my first value will be 95. Then 90, 85. Every time it will decrease by 5. Therefore, here I will have 5. But what is my start value? 95. Okay. So for this question, you will write this. Since it says all 2-digit positive integer numbers, here, attention. Now it decreases 95, 90, blah, blah. After 10, what will be the next value in the loop? It's 5. But 5 is not a 2-digit positive integer numbers. It is single digit. In order to make it 2-digit number, I have to write here, as long as it is greater than 9, I have to continue. So when it is in increasing order, when we have a for loop which generates an increasing order, let's copy this. Here, if it is plus equal, for example, I have something like less than 100. Okay, start with 10. So if it is increasing, the condition has to be something like less than some value because it increases. In this case, for example, I have 10, 15, 20, 25, blah, 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 90, 95. Okay, it is increasing. Therefore, my condition has to be less than 100 because next time it will be 100 and it shouldn't take this because it's not a 2-digit number. Therefore, since it is increasing, my condition has to be less than something. Since here it is decreasing, let's take these values, put them here. Since it starts with 95 and every time we decrease by 5, after some time it will go below 10. So my condition will be as long as it is greater than 9 or as long as it is greater or equal to 10. I can write it like this as well. Okay. As long as it is greater or equal to 10, 95 is greater or equal to 10, 90 is greater or equal to 10, etc. 15 is greater or equal to 10, 10 is greater or equal to 10. But since it is decreasing, after 10 or some value, it will be less than 10. So my condition have to be greater than or greater or equal expression. Okay. If it's a decrease, if you decrease, the condition have to be greater than or greater or equal to. If it is increasing, then it has to be less than or equal. We can also write here less or equal to, as long as it is less or equal to 99, then it's a 2-digit number. If you just change this to, instead of 2 digits, 4 digits, then it's 4 digits. Okay, and this is 4 digits. If I have, for example, 4 digits, of course, the biggest 4-digit number divisible by 5 is this one. If my question is write a for loop that prints all 4-digit positive integer numbers divisible by 5 in decreasing order, what is the biggest number? It is this one. Okay, so the answer of this question will be something like this. Since it is 4-digit positive numbers, it has to start with this one. This is the biggest 4-digit positive integer number divisible by 5. And as long as I am interested in 4-digit numbers, it has to be greater than 1000. Otherwise, if it is less than 1000, it is not 4-digit number anymore. Okay, so you have to be please try to write similar examples. Probably in my lecture notes there must be some exercises here. Try to do these exercises. I will do that one. But this requires, okay, we can do this with while loop or for loop. We can do it with a for loop as well. But I will look and find something interesting. This can be done with a while loop. Don't do it with a for loop. You can do it with a for loop, but a while loop is much better, much suited for this question. All of these exercises, or at least these exercises, can be done more easily with a while statement. What I will do, I will check my question bank. I have a nice question bank. Question bank with for and increasing. Let's go here. Let's take a question. A and B are integer variables containing values, and A is greater than B. Write a for loop that prints all numbers from A to B that are divisible by 10. Okay, that's a good question. Let's copy this. Let's go here. I will solve this one. And A is less than B. This is the question. This is for making bold. A and B are integer variables that has some values. We don't know what they contain. 25, 67, whatever it is. We don't know their values. And we know that the value of A is less than the value of B. Write a for loop that prints all numbers from A to B, both inclusive, that are divisible by 10. For example, if A is 25, B is 136, my program segment will print from 25 to 130 divisible by 10. What are the values divisible by 10? Between this 30, 40, blah, blah, up to 130, okay, from 25. Or what if we have 244, 54, and 1360? Starting from this number up to here, what are the numbers divisible by 10, 260, 70, blah, blah, including B? The last value that will be printed is this one. So how can I write something like that? So my first value is B. What I will produce all numbers from A to B. My solution will be something like that. Produce all numbers starting from A to B. So N, the initial value of N will be A. What will be the last value of B, N? It will be B. Every time increase by 1. Since I don't know if A is divisible by B 10, B is divisible by 10, what I have to do, I have to produce all numbers. Let's take this one, for example. Control C. Let's take this one. for this case, what I will do, I will produce 25, 26, 27, 28, blah, 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 135, 136. I will produce all numbers starting from A to B using this. N is equal to A, so the initial value is A. Every time increase by 1, 25, 26, 28. And as long as it is less or equal to B, as long as it is equal to B, continue. So this for loop will generate all values starting from A up to B, including both A and B. Is this okay? Or if A is 210, blah, 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 let's take this, Control C, let's go here. If this is the case, then what we are producing 254, 255, 256, blah, 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 1359, 1360. So this for loop will produce all numbers. But we are only interested in printing the numbers that are divisible by 10. So we cannot directly print it. What do we have to do? We have to check if the generated number is n, is divisible by 10 or not. So if n modulus 10 equal 0 means that n is divisible by 10. When I divide n by 10, what is the remainder? When it is divisible, it is 0. So here, let's put this one, and here that. Now this is the answer of this question. Okay. If in the exam this is asked, you will write only this. Generally, what I do, I specify in the questions that do not write whole program. Do not write the whole program. Write only the necessary Java statements. Okay. These are the only necessary Java statements to perform that question, to solve that question. Okay, is this understood? You don't need to write public class blah blah, public void int main blah 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 blah, etc. Or public static public int main blah blah. You don't need to do this kind of things. When in the exam you are asked such a question, usually I tell what to do, what to write. Your answer will be something like this. Is this example understood well?
Yes.
And thank you. The first quiz and the quizzes will be done online. And the first quiz, I will do the first quiz probably on week 6. Now we are on week 3. So in 3 weeks time, you will have the first quiz. And this is one of my questions in my question bank. Maybe a lucky student may get this question. Anyway, maybe not. I can change the question a little bit instead of by 10. If the question is that are divisible by 8, what will happen? Assume that the question is not that by divisible by 10, but by 8. The only change is here. This 10 is replaced with 8. If n modulus 8 is equal to 0, it means that n is divisible by 8. Okay. The meaning of this is that n is divisible by 8. The question can be something like that. A and B are integer variables, and A, comma, B and C are integer variables. Now I changed the question a little bit. We have 3 integer variables, A, B, and C. Write a for loop that prints all numbers from A to B that are divisible by C. What will happen? We will change this to C. And n is divisible by C. Okay? Quite simple, isn't it? A, B, and C are integer variables. Print all integer numbers from A to B that are divisible by C. So generate all numbers from A to B. Check if it is divisible by C. If it is divisible by C, then print that number. Okay. I hope this is understood too. Now let's write a for loop with double values. Write a for loop that prints (1.1), (2.2), 3.3 up to 9.9. Okay, these are my numbers we printed. I want to print 1.1, 2.2, 3.3, blah blah up to 9.9. Okay, what will be my for loop? Let's say this time, let's use the variable x. What is the initial value? 1.1. What is 1.1? It's a double variable. 1.1. Okay. So since my first value is 1.1, I will put here double x. 1.1 is not an integer value. Therefore, I will use a double variable. What is the last value? 9.9. What would be the next one? What is the increment? Every time it is increased by 1.1. From 1.1 to 2.2, it is 1 point increased by 1.1. From 2.2 to 3.3, it increased by 1.1. So here I will, after the condition, here I will have a condition. But the increment is that x is increased by 1.1. Okay. Do we agree on that? So what is the condition? As long as x is less than 10, 9.9, 1.1 is less than 10, 2.2 is less than 10, 3.3 is less than 10, 9.9 is less than 10. If I add 1.1 to 9.9, what would be the next number? 11.0. Okay. My condition should be true for all these numbers, but not for the next number. So the condition have to be something like that. I can write either 10 or 10.0, doesn't matter. As long as it is less than this, it will be okay. Is this okay? Is this fine? Let's change this a little bit. 10.1, 11.1, 12.1, 13.1, etc. Up to, as long as it is less than 100. As long as it is blah, 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 blah. As long as it is less than 100, do that. So my initial value is 10.1. My first value is here. My condition, it is as long as it is less than 10, it's less than 100, continue to do that. From 10.1 to 11.1 or to 12.1, what is my increment? It is increased by 1. Okay. Is this understood? So in a for loop, it is not limited to integer variables. I can use double variables. Now, one more thing. Starting from what is 1.1 over 2? 1 over 2 can also be written as 0.5. Okay, 0.5. Next, 1 over 4, 1 over 8, 1 over 16, etc. Blah, 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 blah. I can start with 0.5. What is half of 0.5? 0.25, which is 1 over 4. Half of this, 1 over 8, is 0.125, blah, blah, blah. So as long as this value is greater than, greater than 0.001, because it is diminishing, okay? The value is going down. It becomes smaller and smaller. I want to find the sum of all these numbers, this plus this plus this plus this, etc. As long as a new term is greater than 0.001, or even more. Let's put 1. Write a Java program. It is even bigger anyway. Write a Java program that computes so it is 1, 2, 3, 4 zeros. 1 was it. Write a Java program that computes and outputs the sum of the series. This is the series 1 over 2 plus 1 over 4, 1, 8, etc. 1 over 2 to the power n, because this is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, etc. Okay, as you see that 2, 4, 8, blah, blah, is 2 to the power n. Every time we divide the previous term from 1 over 2 to 1 over 4, it is divided by 2. From 1 over 4 to 1 over 8, it is divided again by 2. From 1 over 8 to the next one, which will be 1 over 16, because it is 2 to the power n, every time it is divided by 2. So my first expression is 0.5, okay? 1 over 2, the first term is 1 over 2, which is 0.5. So my initial value is 0.5. What is my expression here? Divide equal by 2.0. Every time divide this x, which is 2, 1 over 2 is 0.5. Divide this by 2 to get the next one. Divide 1 over 2 by 2, we get 1 over 4. Divide 1 over 4 by 2, we get 1 over 8. Divide 1 over 8 by 2, we get this. So every time the 2 to the this next term is half of the previous term. By looking to this series, we understand this, okay? So every time the new term is this. As long as x is greater than, we have here the condition. As long as a new term is this one, do that. So here, double series equal to 0 at the beginning. What do we have here? At the new term, because x is the new term. 1 over 2 is x, which is 0.5. The next one is the next value of x, because we divided by 2. Okay, so what do? Here we say series, add the new term x to the series. Okay, it says write a Java program that computes and outputs. Since it says outputs, what do we have to do? Go here, system.out.println series. This is to satisfy this output part. Okay, compute sum of the series. Here we are computing the series, and here we are outputting. Is this understood? So for loops in Java are also quite powerful. You can do this kind of things. Okay, start with a term. This is the first term, 1 over 2. Every time the new term is half of the previous term, from here, by looking to this, you can understand this. The below the denominator of the terms is multiplied by 2 every time. 2 multiplied to 4. 4 multiplied by 2, 8, etc. And we see here 2 to the power n. 2 is 2 to the power 0. 4 is 2 to the power, 2 is 2 to the power 1. 4 is equal to the 2 to the power 2, 8 is 2 to the power 3, etc. So 16 is 2 to the power 4, etc. So when you carefully examine this expression, this series, you will see that every time the next term, or let's say even make it better understandable, term is equal to 0.5, the first term, the next term, as long as a term is greater than this value, compute the next term and add the new term. Probably this is even by using the English variable name term, this will be much better. I hope this is understood. The answer of this question is this 5, 1, 2, 3, 4 lines, except the curly braces. This is solved in just 4 Java statements. Okay. Is this understood?
Yes.
Thank you. Okay, I will finish my lecture now. Next week we will continue with the while statement. So I will just write this here. We have done if, so CS102. Next subject will be while statements. What I did today. Last time, the last thing that I did is this one. So I'm recording because I'm an old man. In order not to forget, I'm just write here in CS102, 3.5 is explained. Next time I will continue with 3.6. Okay, if you have any question, I will be glad to listen and answer your question.
Hocam benim bir sorum var.
Tabii buyur.
Hani for loop'un başında